Good morning, students and viewers. Welcome again to Elimu Live. With you today is Mr. Allan Yonga. Allan Yonga is a maths and chemistry teacher at St. Joseph, Liabai. Today I'll be taking you through chemistry. And in chemistry, some questions, in KCSE, there are some questions which involve theory, and also there are some questions which also involves calculations. So one of the topic which involves calculations, and it's easy to understand, is gas laws. Gas laws. When we hear the word gas laws, a student who is a backbencher somewhere might be thinking we want to talk about when or how to fart. Talking of farting, I've heard that farting, we spread COVID-19 through farting, though no scientific reason has been given. Anyway, back to gas laws. When we will be talking on pressure and temperature and volume, how does those three conditions affect gas? And there are two laws which we'll be looking at. The first law is Boyles Law, and the second law is Charles Law. We have said there are three conditions: pressure, volume, and temperature. So in Boyles Law, we'll be talking of pressure and volume. How does pressure and volume relate? On Charles Law, we'll be talking on volume and temperature. And here, to be specific, absolute temperature. So our temperature will be in Kelvin. So for you to understand these two laws, then we can combine these three laws and we'll have the combined equation. Combined gas law equation. So when you combine Boyles Law and Charles Law, you get combined gas law equation. For you to understand the laws well, there are two terms, mathematical terms, which you should understand also. These two terms are direct proportion and inverse proportion. What does direct proportion mean? Direct proportion means when one quantity increases, also the other quantity increases. When those two factors both increase, or when one decreases and the other one decreases, thus the relationship between the two quantities is they are directly proportional. Let me give a real life situation. Like when you talk of maturity and wisdom, and maturity here necessarily doesn't mean age, they are directly proportional. The more mature you are, the more wise you become. Now, the other one is inversely proportional. Inversely proportional now is the opposite. When one quantity increases, the other one decreases. The other one decreases. So if a substance decreases, the other one increases. And a good real-life situation is if you have been keen on the updates which we are being given by the Ministry of Health, you'll notice that when the number of people who have been recovered, of the patients who have been recovered, increases, the number of deaths decreases. So those two, recoveries and number of deaths, are inversely proportional, since one quantity increases and the other one decreases. So if you have understood those two terms well, then it will be easier to know what Boyles Law states and what Charles Law states. Let me start with Boyles Law. Boyles Law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. at constant temperature. So that's why I was insisting on the understanding the words inversely and directly. So what does it mean? That the volume of a fixed mass of a gas, if I have a fixed mass of a gas and I have its volume, the moment I increase the volume, the pressure will decrease because of Boyles law, which states that the volume of a fixed mass of a gas is inversely proportional to its pressure. Volume is inversely proportional to its pressure at constant temperature. We have to emphasize at constant temperature. So that means you don't tamper with the temperature. If the temperature remains constant, the moment you change the volume, you increase the volume, the pressure will decrease. A good real-life scenario is when you have an inflated balloon and you try to press it. When you press the balloon, it will be popping out here. And if you press it harder, it will eventually burst. Why? As you are pressing it, you are decreasing the volume. While you are decreasing the volume, you are increasing the pressure. So the pressure inside builds up and eventually it bursts. This law can be represented graphically. So let's see how we can represent the law graphically. So graphically, if you have values of pressure in the y-axis and volume in the x-axis, we have said the moment the pressure will be high, volume will be low. So if I have here high pressure, the volume will be low. So that's how the graph appears when you draw a pressure against volume. So you can see here at this point, the pressure is high, but the volume is low. At this point, the volume is high, but the pressure is low. So sometimes you can be tested to draw a graph of pressure against volume if the gas obeys Boyles law. So if the gas obeys Boyles law, that's how the graph should look. The law can also be represented mathematically. Let's see how we can represent the law mathematically. So volume of a fixed mass of a gas. So we say volume 1 over P. So this sign is alpha. It's a Greek letter meaning alpha. So alpha stands for proportion. So if you say 1 over P, it means volume is inversely proportional to pressure. If you want to change alpha to be an equal sign, you introduce a constant K. So V equals to K over P, where K is a constant. From there, we can make K the subject. You multiply both sides by P. So that gives you K equals to PV. If I multiply this side by P, P cancels out. P times V becomes PV. So PV is a constant. What does it mean? It means if I have a certain pressure of a gas and a certain volume of a gas, anytime I change one of the conditions, it will still remain as a constant when I'm multiplying the two. So K equals to PV is what we refer to as the Boyles equation, which gives us an equation which is P1 V1 equals to P2 V2. And that's the Boyles equation. P1 V1 equals to P2 V2. Why P1? Anytime the pressure of a gas and the volume of a gas, it's usually a constant. It will never change. The product of pressure and volume of a gas will always be a constant. Having discussed the Boyles law, we can look at examples where you'll be tested using Boyles law. First, you can be tested to state the Boyles law, which we have stated here, what it states. You can be told to represent it graphically, and the equation, you can apply it in a question or in an example like this one. So we'll say we can take a gas which is in the atmosphere, like carbon dioxide. So the pressure of carbon dioxide, these are examples which involves Boyles law. The pressure, carbon dioxide, the formula is CO2. The pressure of carbon dioxide is 760 mmHg. That's a unit for measuring pressure. Millimeter of mercury that's the unit for measuring pressure, is the pressure is at 30 centimeter cubed. So that's the volume. The volume is 30 centimeter cubed, and the pressure is 760. Calculate its volume when pressure is adjusted to 600 mmHg. So there's a question there you have been given. The pressure of CO2 is 760 mmHg at 30 centimeter cubed. Centimeter cubed thus tells you its volume. Calculate its volume when pressure is adjusted to 600 mmHg. Earlier, I indicated that Boyles Law deals with pressure and volume. So if you have been given those two conditions, automatically my mind should hit that I'm applying Boyles Law. So Boyles Law equation is, so the solution will be, you say P1 V1 equals to P2 V2. That's the Boyles equation. Then P1, what is your P1? The first pressure is 760 mmHg. What's your V1? The initial volume was 30 cm cubed. P2, what's your P2? P2 is what we have been told to find. Sorry, P2 we have been given, it's 600 mmHg. When pressure is adjusted to 600 mmHg. Calculate its volume. So V2 is what we are calculating. So having written the values which you have, you now get the unknown by replacing those in the formula. So you say 760 times 30 equals to P2 600 times V2. Now here you apply your knowledge of mathematics. If I want to remain with V2, I divide both sides by 600. So divide here by 600, divide here by 600. So that this 600 and this 600 goes out. Then you take your calculator, which will assist you to get the correct answer. So 760 times 30, then divide by 600. That gives you a volume of 38 centimeter cubed. So V2 equals 38 centimeter cubed. So that's an example where you can apply Boyles Law. So let me dictate. I know you are fast and you are, let me dictate the question for you so you can attempt during your free time. This one here now will take nitrogen gas. Nitrogen gas occupies a volume of 20 liters at a pressure of 40 pascals. At a pressure of 40 pascals. Pascals is another unit for measuring pressure. What will be its volume if the pressure is reduced to 30 pascals? What will be its volume if the pressure is reduced to 30 pascals? Let me repeat it again. Nitrogen gas occupies a volume of 20 liters at a pressure of 40 pascals. What will be its volume if the pressure is reduced to 30 pascals? You can attempt that, and if you have any inquiry, always use the numbers under your screen to forward your questions. With having discussed Boyles Law, swiftly we can move to Charles Law. The second law, which is Charles Law. Charles Law, if you remember well what I said earlier, it involves volume and absolute temperature. The key word is absolute temperature. Charles Law. So what does it state? It states that the volume of a fixed mass of a gas is directly proportional. It's directly proportional to its absolute temperature at constant pressure. To its absolute temperature at constant pressure. So that's what Charles' law states. Volume of a fixed mass of a gas, the keyword is volume, is directly proportional. What did I stated those two terms. The easier way to understand the laws, if you understand the terms directly, proportional. When one increases, the other one increases. When one decreases, the other one decreases. Directly proportional to its absolute temperature at constant pressure. Here you hold the pressure to be constant. You don't change the pressure. A good real life scenario example on Charles' law, let me share my story. When I was a small boy, I used to have a basketball, and my mom used to warn me every time, don't leave the ball on the floor overnight. But she never explained why I shouldn't leave the ball on the floor overnight. So the only reason she could give me is God has punished you for not obeying me. But she didn't explain. The moment I woke up in the morning, I'll find the ball has shrinked. The ball has shrinked. So if I ask her, why did this happen? She tells me, God has punished you because you don't listen to me. Only when I got to high school, then I was explained Charles' law, and I knew and I understood what was happening. So when you leave the basketball on the floor, since at night it's very cold, the ball absorbs the temperature is lowered since of the cold environment. And if the temperature is lowered, what happens to the volume? The volume also decreases, sorry. Yeah, it's directly proportional. So if the temperature is lowered, also the volume decreases. And that's what was resulting to the ball shrinking. So that explains Charles' law. And even if you have a car at home or a bicycle, normally in the morning you'll find that the tire it's deflated. The reason is because low temperature, low volume, according to Charles' law. So we'll also show Charles' law graphically, the way we did with Boyles' law. So graphically, how can you represent Charles' law? And here you are drawing temperature against volume. So if you have volume here and you have temperature, what kind of graph will it give you? It will give you a straight line, because both are increasing. If temperature is high, volume is high. If temperature is low, volume is low. Let's see mathematically how we can represent it. Mathematically. So mathematically, we use the word alpha. Alpha is what we use to represent proportional. So we say V is proportional to T. They are directly proportional, so I don't say 1 over T. If I say 1 over T, it will be inverse proportional. Then you introduce a constant. The moment you introduce a constant, you also have to introduce an equal sign. So V equals to KT. V equals to KT. Then make K, the constant, the subject. So to make K the subject, we divide both sides by T. So K will be K equals to V over T. So if a gas obeys Charles' law, it means its volume divided by its temperature will always be a constant. Its volume divided by temperature will always be a constant. So this gives us the Charles' law equation, which will be V1 over T1 equals to V2 over T2. And that's the most important equation in Charles' law. That's the most important equation, which will be applying V1 over T1 equals to V2 over T2. So also same as Boyles' law, Charles' law, you can be tested to state what it states or to write what Charles' law states. You can also be asked to show or to represent it graphically, and there are some questions which will be involving the application of the formula. So I'll look at an example where we can apply that formula V1 T1 equals to V2 over T2. V1 over T1 equals to V2 over T2. Students, I'm still emphasizing chemistry questions involving calculations. That's where you should always be gaining a lot of marks, or you should garner a lot of marks, because they are easier to understand and you just follow the procedures. It's kind of difficult compared to theory questions where you need to do some explanation and analysis. These ones, if you are good with the formulas, then you're okay. So the example which we are going to look at is helium gas. Helium gas has a volume of 23 centimeter cubed at 5 degrees Celsius. Calculate its temperature. Calculate its temperature at 30 centimeter cubed. Calculate its temperature at 30 centimeter cubed. Before we look at the example, let me explain something. We say that the volume is directly proportional to absolute temperatures. Always when we are applying this formula, your temperature should always be in Kelvin, because absolute temperature is in Kelvin. So how do you change degrees Celsius to Kelvin? When you want to change degrees Celsius to Kelvin, not Kelvin, Kelvin, you add 273, and when you're going backwards, you subtract 273. So if I have 0 degrees Celsius, to change it to Kelvin, it's 0 plus 273. That will be 273 Kelvin. If I have 5 degrees Celsius, I'll add 273. That gives me 278 Kelvin. So 5 degrees Celsius is the same as 278 Kelvin. The reverse, you subtract. Going forward, you add. So that's the where most students usually go wrong. They apply the formula well, but they forget to change the temperature to Kelvin. So make sure always your temperature should be in Kelvin. So back to our example. So solution. So you check what you have been given. If you have not been given pressure, don't involve Boyles law. If you have only been given, if the pressure is held constant, it doesn't change. That automatically means it's Charles law. So Charles law formula, V1 over T1 equals to V2 over T2. So what's our V1? V1 is the first volume, which was 23. What's your T1? 5 degrees. But you add 273 so that it can be in Kelvin. That's 278. All right, what's your V2? V2 is 30 centimeter cubed. What's your T2? T2 is what you have been told to calculate. Calculate its temperature at 30 centimeter cubed. Now substituting the values in the formula. So it will be 23 over 278 equals to 30 over T2 equals to 30 over T2. To solve this, since they are fractions, the best way you do cross multiplication. Cross multiplication means you do 23 times T2 equals to 278 times 30. That gives you 23 times T2 equals to 30 times 278. Then mathematically finding unknown, since I want T2, divide both sides by 23 over 23 over 23. So T2 equals to 30 times 278 divided by 23. Let's use our calculator. At home, you can also dial your calculator so that you get the answer before me. So 30 times 278, then divided by 23. That gives you 362.6. 362.6 362.6 Kelvin. Remember we said in the formula the temperature is always in Kelvin. So you be keen, if they have indicated what's the temperature in degrees Celsius, I'll have to subtract 273 to change it back to degrees Celsius. So if I want it in degrees Celsius, I'll say 362.6 minus 273. 362.6 minus 273. That should give you 89.6 degrees Celsius. So those are your two answers. But it depends with the question how it has been structured. If they specify what's the temperature in degrees Celsius, then you give your answer. You have to subtract 273 so that you get 89.6. So those are the two laws. Before I combine the two laws, let me do a recap of the laws. The first law was Boyles Law. Boyles Law, we have said it involves pressure and volume. And we say, how do they relate? Pressure of a fixed mass of a gas is inversely proportional to its volume at constant temperature. If pressure increases, volume decreases, and the temperature is constant. And we said those two gives you the formula P1 V1 equals to P2 V2. Then we have looked some couple of one example. We've looked at one example. The second one I told you you can attempt. We came to Charles Law. Charles Law now deals with volume and absolute temperature. The volume is directly proportional to the absolute temperature at constant pressure. Here you hold the pressure constant. You don't change the pressure. And that's how you represent it graphically, and that's how you present it mathematically. I've done one example here, and I've emphasized that the temperature should always be in Kelvin. The temperature should always be in Kelvin. And please be keen on that, because most students have noticed that's where that's the common error most students make. So to change to Kelvin, you add 273. Degrees to Kelvin, add 273. Kelvin back to degrees, you subtract 273. I did an example here, and let me give you one example also which you can attempt at home, of which I'll dictate. The volume of oxygen gas, I hope you are ready with your pen. The volume of oxygen gas is 600 centimeter cubed. The volume of oxygen gas is 600 centimeter cubed at 20 degrees Celsius. At 20 degrees Celsius, that's 20. Calculate its volume. Calculate its volume if the temperature is increased to 35 degrees Celsius. Calculate its volume if the temperature is increased to 35 degrees Celsius. Let me repeat it. The volume of oxygen gas is 600 centimeter cubed at 20 degrees Celsius. Calculate its volume if the temperature is increased to 35 degrees Celsius. So you can attempt that during your free time. So let me move to now combined equation, combined gas law equation. Combined gas law equation. So in combined gas law equation, here now you combine the two laws, Boyles Law and Charles Law. Combined gas law equation. And this equation will be applying where the conditions, remember in the two examples, one condition was being held constant. In Charles Law, you hold the pressure constant. In Boyles Law, you hold the temperature constant. But now in combined gas law equation, everything changes. You change the pressure of the gas, you change the temperature of the gas, and also the volume of the gas will change. So when you combine that equation, you get the combined gas law equation. So let me start with we have P1 V1 equals to P2 V2. That was Boyles Law equation. We have V1 over T1 equals to V2 over T2. This is Boyles Law equation. This is Charles Law equation. When you combine them, now you get P1 V1 over T1 equals to P2 V2 over T2. That's the combined gas law equation. Combined gas law equation. And actually is one of the most important equation when we talk of gas laws, our topic today. So P1 V1 equals to T1. P1 V1 over T1 equals to P2 V2 over T2. Here there's nothing to state. We just apply the formula, and I'll do examples which involve those formulas. So the first example, to be a given mass of a gas, a given mass of a gas has a volume of, or occupies a volume of 30 centimeter cubed at negative 15 degrees Celsius and 760 mmHg. What will be its volume at 27 degrees Celsius, at 27 degrees Celsius and 680 mmHg. mmHg, remember, is the unit for measuring pressure. I hope it's clear there when you're at home. So that's the equation. We want to look regarding combined gas law equation. A given mass of a gas occupies a volume of 30 centimeter cubed at negative 15 degrees and 760 mmHg. What will be its volume at 27 degrees and 680 mmHg? So a student might forget and use the Boyles Law equation, P1 V1 equals to P2 V2. Another one might use V1 over T1 equals to V2 over T2, because you have been given all those three conditions, pressure, volume, and temperature. But one thing you have to be keen on is all the conditions have changed. The temperature was negative 15, it has changed to 27. The pressure was 760, it has changed to 680. So even the volume will change from 30 to something, and that's what we need to calculate. So what will be the solution? So the formula is P1 V1 over T1 equals to P2 V2 over T2. P1 V1 over T1 equals to P2 V2 over T2. Now identify your P1. Your P1 was 760. What's your V1? Your V1 was 30. And what's your T1? Negative 15. But we said volume and temperature value when the temperature is in absolute temperature. So I have to add 273 to change it to Kelvin. So negative 15 plus 273, very fast with your calculator, that gives you 258 Kelvin. Let's identify our P2. P2 pressure is 680. What's our T2? 27 degrees, which we have to add plus 273 to turn it to Kelvin. That should give you 300 Kelvin. V2, that's what you have been told to calculate. V2, what's your V2? So now substitute this in this formula. So we say 760 times 30 over 258 equals to P2 680 times T2 300 over, sorry, not T2, times V2. It's P2 times V2. So here we have V2. V2 we don't have it, so I don't indicate any. Make that correction. V2 is not 300. 300 is T2, so 300 comes down here. When you have questions which are in fraction form, an easy way to solve them is cross multiplication. So you do cross multiplication, which will be 760 times 30 times 300. All this is being multiplied by 30. So 760 times 30 times 300. So you get 6 million or 6.84 million. 6,840,000 equals to 258 times 680 times V2. So let me do 258 times 680. You get 175,440 V2. V2. You get 175,440 V2. Where is the V2 coming from? Here. Let me repeat where we are getting these values so you don't think it's a budget. So 760 times 30 times 300, that we did cross multiplication, that gave you 6,840,000. 258 times 680 times V2 give you this. Now, because we want to remain with V2, you divide both sides by that 175,440, so that it cancels out. Also same side, the other side I do the same thing, divide by 175,440. So when you do that, we say 6,840,000 divide by 175,440. That gives you 38.99. So V2 equals to 38.99 centimeter cubed. 38.99 centimeter cubed. And that's how you apply combined gas law. I hope that explanation was clear and you're able to understand. I'm still reminding you, if there's anywhere where you don't understand, always don't hesitate to use the numbers on your screen and send your questions. Since we have time, I can look at example 2, still on combined gas law. Okay. We can look at an example. Or instead of doing an example, I can give you a question which you can attempt while you're at home so that you become busy. During this time where you're practicing social distance, at least so that you avoid a lot of thoughts, especially negative thoughts, you need to keep yourself busy. And being a student, one way of keeping yourself busy is try to remind yourself what you have learned while you are in school, and also when you are at lower classes. Maybe if you are in Form 4, what you have learned in Form 1, 2, and 3. If you are able to revise what you have learned, then when school resumes, you'll be at added advantage because you have done something and now you'll be having something small to just revise on. So I'm sure most of you have access to internet. So first, get the meaning. So assignment, you explain these two terms, standard temperature and pressure. So you explain standard temperature and pressure and room temperature and pressure. So the internet or your Form 3 chemistry textbook will be of great assistance to know the meaning of those two terms. Question 2. Question 2. Hydrogen gas hydrogen gas has a volume of 360 centimeter cubed at 51 degrees Celsius, and 540 millimeter Hg, or mercury, for 40 millimeter of mercury. Calculate its volume. Calculate its volume at, question 1, RTP, and 2, at STP. RTP and STP. RTP and STP are initial standing for, STP is standard temperature and pressure. RTP is room temperature and pressure. So for you to tackle question 2, it means you must have done the first assignment, which you have to understand what STP and RTP means. Yeah. So that's my lesson today, for today. And during the next lesson, we'll do more questions involving calculations in chemistry, because that's where it's easier to get a lot of marks. Thank you.